Okay, we're in a new chapter, chapter 9, and 9.1 deals with adding and subtracting polynomials. Now, before we get into the lesson of adding and subtracting, there are some terms that we're going to be using throughout not only this chapter, but as we move forward. And these are the terms that are very helpful, especially when it comes to being able to explain and understand different components of other polynomials. So the first one I have up there is monomial, and that definition is a number or a variable or the product of one or more variables um, with numbers with whole numbers as exponents. And then the next one is the degree of monomial, which is the sum of the exponents of the variables in that particular monomial. And polynomial is a monomial or a sum of monomials, each of which is a term. And then if you ever hear me talk about the degree of a polynomial, which is defined as the greatest degree of its terms, the lead coefficient is, if you remember what I talked about, coefficient is the value that's attached to a variable. Well, the lead coefficient is that number with that is attached to the variable that has the highest degree. Binomial means it's a polynomial with 2 terms, and trinomial is a polynomial with 3 terms. A lot of this will make a little bit more sense when you start seeing problems and when we're dealing with solving these problems in particular expressions. When dealing with polynomials, it's actually a shorter list to give the reasons why it's not a polynomial rather than the list of what makes polynomials. So here are the main parameters to look for that are not polynomials. First one is it a fractional or decimal exponent? They must be whole numbers. Is the variable in the denominator? So if x is in the denominator, it cannot be a polynomial. If the variable is an exponent, so if I say like 5 to the x power, that means that it's not a polynomial. And the last thing is if we have a negative exponent, like say 3 to the negative 4 power. So these are the classifications of what would not make a polynomial. So for these first examples I have here, I want you to A, tell whether the expression is a polynomial, and if it is, rewrite it in standard form. Now, standard form means that you're going to take what was called the degree of polynomial, so you're going to take it in the largest degree of whatever variable that may be, and then consecutively take those variables downward and write those equations or expressions as followed. I want you to find what degree it is. I want you to find its lead coefficient and then classify it by the number of its terms, or otherwise tell that it's not a polynomial. So let's look at A. A, I have 3x. So first I need to check, does this fit any of the criteria that was given for why it could not be a polynomial? Like, is it a fractional or decimal exponent? Does it have variables in the denominator? Does it have a variable exponent? Does it have a negative exponent? It does not have any of those parameters, so I can say that yes, this is a polynomial. So for A, I can say it's yes. For B, it says rewrite it. Well, it's just a monomial. It's just one term, so I can just write it as 3x. So it is what it is. For C, it's asking for the degree. So you're looking for the exponent that's attached to the variable. Since it doesn't have one, this can be written as like x to the first power. So the degree for this particular expression would be 1. D, they want us to tell us what the lead coefficient is, and that lead coefficient would be the number 3 because it's the largest degree that's attached to that variable for that number. And then for E, they want us to classify it by its terms. Well, since it's just one number and one term, I can say that this is a 1-degree polynomial, or monomial, I'm sorry. Okay? But look at B, I have a problem. As you can see here, I have a negative exponent. And so since that was one of the parameters that would tell you that it was not a polynomial, so since it has a negative exponent, I can say that this is not a polynomial. There's an in there. Okay, for C, I have 6x to the 5th minus 3x cubed. So for A, is this a polynomial? I can say that is yes. For B, they want me to rewrite it, so they want you to, I want to find the degree with the largest exponent. So it would be x to the 5th, so I'm going to write that one in first, and then 3x cubed. So it was already written in standard form. C, they want to know what the find the degree is, and so the greatest degree is 5, so I'm going to write that here for C. For D, they want you to find what the lead coefficient is, so to the 5th power, the one that's attached, that value that's attached to the variable is 6, so the lead coefficient is 6. And then for E, they want us to classify what type of polynomial this is, and since I just have one variable x, and that largest degree is 5, I can say that this is a 5th degree, and since it's 2 terms, binomial. For D, I notice that my variable is an exponent, which that is one of the stipulations that makes it not a polynomial. So I can just say that this is not a polynomial. And then, let me get some room. For the last one, I have 7x to the 4th y to the 2nd minus 9x y to the 3rd plus 4x squared y. So is this a polynomial? I can say yes, it is. It does not fit any of the criteria that it would not be a polynomial. For B, they want us to rewrite this in standard form. And when we're looking at the variables for degrees, they usually want to treat x as the, well, for this case, the exponent or the variable with the biggest degree is to the 4th power. So that's the one that I'm going to write in first. So that's going to be 7x to the 4th y to the 2nd. Then I see that this term here has x to the 2nd, while this one here just has x to the 1st power. So I'm going to write 4x squared y before I write in my minus 9xy cubed. So it was the way it was rewritten was dictated on the largest degree that was attached to that particular variable. So if the largest variable was attached to, say, the y value, then I could use that to I would use the y value in order to rewrite this in order. So for C, they're asking for the biggest degree, which is x to the fourth, so it's a fourth degree, so it would be 4. For D, they want to know the lead coefficient, so the lead coefficient here would be this value here, which would be 7. And then for E, they want to know what the classification is. So the classification would be is you would take the value of these lead numbers and add them together, so then this would make it a 6th degree trinomial, because there's 3 terms here, 1, 2, and 3. Okay, so let's get to adding polynomials. Adding polynomials is basically being able to take them out of the parentheses and then finding like terms. So what I'm going to do for adding them, it's quite simple. So for the first parenthesis here, I'm just going to take it out of the parentheses. So I got 3x cubed minus 4x squared plus 7. Then because it's adding the polynomial, what you're going to do is you're just going to, how it's written in that second parenthesis, you just leave it as is. So it's going to be minus 5x cubed minus 2x squared plus 10x plus 11. So from here, you must find the like terms. So I'm going to underline the 3x cubed. Do I have any other x cubed values here? Yes, I do. I have that one right here. So what I need to do is I need to combine those like terms. So 3x cubed minus 5x cubed will give me a negative 2x cubed. Okay? And now since I've combined those, I'm done with those, so I can just kind of cross it off. Now I need to find the next variable with the biggest degree, which would be x squared. So I need to find like terms in x squared, which are the negative 4x squared and the negative 2x squared. If I combine those, I get minus x squared. Since I've finished with those, I can cross those out. Next thing is, do I have any just x to the first power? Yes, I do. I just have the 1, so it's plus 10x. Cross that out. And then the last ones would be the constants. The constants don't have any variables attached to them. And if I add those together, I will get plus 18. And that is my answer for that particular polynomial sum. If I look at B here, I have x squared minus 4x plus 11 plus 13x squared plus 19x minus 19. So again, I'm just going to rewrite it without the parentheses. And since it's adding, I treat that second parenthesis how as is. So if that was a positive 13, so that's going to be plus 13x plus 19x. That's 13x squared, I'm sorry. And then all we have to do is combine like terms. So I have this one here and this one here. And we must remember that even though it just says x squared, this is exactly like saying 1x squared. So if I have x squared plus 13x squared, the sum is 14x squared. Since I've combined those, I can cross it out. I have two values that have x attached to them, and negative 4x plus 19x would give me a plus 15x. Cross those out. And 11 minus 19 will give me a negative 8. So the sum of those two polynomials will give me 14x squared plus 15x minus 8. If I was dealing with subtraction, it's a little bit different. When you take them out of the parentheses, the first set of parentheses, you write them just as is, exactly the same. So it would be 9x squared minus 7x plus 1. But because it has the subtraction problem right here, the second parenthesis, I must change the sign in each of the values that are inside those parentheses. So if I have a negative 3x squared, that means I'm going to have a plus 3x squared. If I have a negative 7x, that means I'm going to have a plus 7x here. If I'm going to have a plus 9, that means I have a minus 9. So that's the big difference between addition and subtraction, is that second parenthesis. You leave it as is when you're dealing with the sum, but you change the sign of each of the values when it comes to subtraction. Keep that in mind. So now from here, you do exactly the same thing you did when you were dealing with the sum. You're going to combine like terms. So I got my 9x squared and my 3x squared here, which will make it 12x squared. Cross those out. I got a negative 7x and then a plus 7x. If I take negative 7x and plus a 7x, that gives me 0. And since it's 0, I don't have to write it in. I can just cancel those two out. You don't need to write in 0. And now I have 1 minus 9, which will give me a negative 8. The only time you'd write in that 0 is if that was the only value and the result of the entire problem was 0. So because it's not in this case, we just write it as 12x squared minus 8. So for the last one, I have, again, the first set of parentheses I write as is, so it's 5x to the 5th minus 8x cubed plus x squared minus 7x minus 6. And then because it's subtraction, everything inside those parentheses, the sign gets changed. So it's a positive 4x to the 4th. Now it's a minus 4x to the 4th. I got a minus 2x cubed. That's going to be plus 2x cubed. I got a minus 8x. It's going to be a plus 8x. I got a minus 7. It's going to be a plus 7. And now I'm going to combine like terms. So I look at x to the 5th, which is my largest degree. Is there any terms here I can combine? No, because there's no other term that has x to the 5th power. So I'm just going to write in x to the 5th power. Cross that out. Is there anything to the 4th power? Actually, this one should be to the 4th power. I wrote that wrong. So, and there's no other one to combine, so I'm just going to leave it as is. So it would be minus 4x to the 4th. Cross that out. I got x cubed here. I have x cubed here. So that would give me minus 6x cubed. Cross that out, cross that out. Squared. I have no other squared values but that, so I just leave it as x squared here. Cross that out. X values. And when I combine those, I will get a plus x or a plus 1x, however you prefer to write that. And then I have my constants. And combining those, I'll get plus 1. So the difference of those two polynomials will give me that. And that is being able to add and subtract polynomials. Hope this helps. Until next time.